Hello! Today I will be showing you how you can use Concord, a free Unreal Engine plugin, to import MIDI data from your computer into Unreal Engine and play that back using a Metasound. To do this, I will first create a simple MIDI melody here in Reaper, then export it, import it into Unreal Engine using the Concord pattern type, and then set up a Metasound that uses the pattern data to produce some audio output. So first let me just add a track to this Reaper file here, and it's just a simple synth, and I'll call this track synth, and then I'll lay down a little melody. So I have a couple of details in this melody, a bit of velocity differences and also some incorrect timings, but I'll just keep those in there and then show you how you can actually reproduce the timings and velocity changes inside Unreal. So let's go ahead and just export the project MIDI to desktop and then switch over to Unreal, and I have the Concord plugin enabled. You can also grab it for free from the marketplace and then follow along as well. So let's open the content browser, and I'll just go into an empty folder here, then click import and then grab the MIDI file that we have just created in Reaper. And we can now import this when the Concord plugin is enabled as a Concord pattern. And we get a couple of options here, number of lines, lines per beat, and ticks per line. Now a line here is kind of like a line in a music tracker. If you're familiar with music trackers, it's like a discrete kind of vertical representation of symbolic music, where we have a couple of lines per beat, usually like 4, and we can fill in musical data on this grid instead of having a continuous timescale as in MIDI. So in our case, we can actually keep these default settings. So we'll have 32 16th notes, and each 16th notes will be subdivided into 6 further ticks, which we can use to create some imperfect timings. I'll just click import. And then if we have a look into our imported pattern data, we can see we have one track, which is called synth, which is the one we've created. And each track has a number of columns, so we can support polyphony, but we have just one column since our melody was monophonic. And in here we have note values, instrument values, volume values, and delay values. Again, these are similar to music trackers. We don't have any data for our instrument values because just a single instrument was used. But in our notes, we have the MIDI note numbers, 0 as a no op, meaning there's no change, no note on or note off, and a negative value, in this case -1 for note offs. And we also have volume values. These are correspond to the velocity values that we've played in our MIDI, so 1 to 127. And then we have delay values. So we see our imperfect timings. Now this ranges from 0 to 5, since we had 6 ticks per line, where 0 is straight on the 16th note, and 5 is the maximum amount of delay. How can we use this data to play back a Metasound? Well, that's the next step. So let's switch back into the content browser and just add a new Metasound and build a setup that supports playing back such a Concord pattern. For this, we have a couple of helper tools that come with the Concord plugin. First, I will delete the one-shot interface and add the Concord interface instead, which sets us up with some useful inputs. Then I will grab a clock, which is one of the custom notes that Concord comes with for Metasound, and I'll connect the on-play with the start. I will also grab the BPM from our inputs and then cast this to float, because the Concord clock actually takes a float BPM. And also the lines per beat I can set using the Concord interface. But next, let's actually create some sound. So the Concord clock will simply produce triggers on each line as it counts through, as a music tracker would do in its playback. It'll just count the lines up to the number of lines specified, and it'll loop around optionally. So let's create a very simple setup that simply plays back our MIDI note data that we have stored in our note values. To do this, I can add another node called getColumn, which is also one of Concord's custom nodes. And I will do this on each line. We could also do the get column simply on play, but then if we would decide to change the pattern while the Metasound is playing, it wouldn't update. So for the future, it's nice to have this update on every line. Obviously, it has some performance implications, but it's negligible in this case. We will use the Concord pattern input from our Concord interface and hook this up to the pattern that we're going to use. Then on this input, we will set the default value to our newly imported Concord, or no, actually it's the MIDI export that we just imported from our desktop. And then we will set the column path. Now these column paths are corresponding to the track names here and the values that we have. So we can use synth/notes to access the notes in our synth tracks. And optionally, we could also provide a column index here in the path. But since we only have a single column, we can omit this. And now we get back our note data. So we will also need a get note on this array, which takes a trigger, and we will once again use the online trigger to get this, and the index is also provided by the clock. So now here we have our note value, or 0 or -1. We still need to check what actually comes in here, because we will want to convert note values to frequencies, but we don't want to convert a 0 or a -1 to frequencies, because those have special meanings. What we will do is we will add a trigger compare, a node right here, and then we will compare on each line whether our note value from our column is greater than 0, so it's a valid note number. And if it is a valid note number, we will once again use a get note to get from our note values the actual pitch. Why do we need another get note? Well, these get notes cache their last value they produce, and we don't want to ever pass 0 or -1 to our frequency conversion, because this is what happens next. We grab this int that comes out of here, and we will convert MIDI to frequency. So we need to make sure that only when this comparison is true do we actually update our value that this node gets from the node values. So now that we have a frequency, we can add a sine oscillator and plug this into the frequency input, and then we'll grab the audio out and plug this in here, and we can take a listen. So this plays back our MIDI that we have input earlier, but obviously there's no gate information. It simply takes the sine os and feeds it into the output all the time, just changing the frequency. So in order to add an envelope to kind of gate this with the node ons and node offs, we will actually grab an ADSR envelope here, and we can use an audio envelope. Could also use a float envelope. It's not that much of a difference here. And we will actually trigger an attack on this whenever we have a note value that is greater than 0. However, we want to trigger the release when we encounter a negative value here in the note values array. So once again, we will drag off the false trigger compare here and add another trigger compare where we check on our index, on our note value, so the note value from here, whether it is less than 0. And in case it is less than 0, we will actually trigger a release on our envelope. And I will make this release a bit more snappy so you can actually hear it, and I'll bring up the sustain to 1, so it'll be the same sound as we had in Reaper at the start. Then we'll just multiply the audio together, and now we have the gate information as well. Next, let's make use of the delay values in our imported pattern to actually reproduce the imperfect timing of our MIDI performance in this Metasound. First, I will take all of these notes that we've created for the note data and move them a little bit to the side. Then I will grab my get column node into the Metasound graph, and we'll connect our pattern input, and the column path, we will set it to synth/delay. Then we will also grab a delay trigger node or a trigger delay, and then just move all of the connections that we've made from the online trigger of our clock to the out of our trigger delay, so that everything relating to our note data and note offs and note ons will be affected by the delay that we compute here. Now we can use the online to trigger the Concord get column for our delay values. Then we'll use again a get node from our data. We'll do this on each line, and we'll check the index from the Concord clock to get our delay. Now we have 6 ticks per line, which means 0 means no delay and 5 means the maximum possible delay. So we'll grab this and just cast this to float, and then we'll divide this by 6. So the number of ticks that there are, which means we don't quite delay at the node all the way to the next 16th node, because this overlap would mess with the melody information, but we'll move it very close to the next one if we have our maximum delay value. But in order to really move this, we need to get a time in seconds. To get this, we need to use our BPM and lines per beat properties or inputs to actually compute the seconds per line. We can easily do this by simply dividing 60 by our BPM to get the seconds per beat, and then dividing this by our lines per beat to get the seconds per line. We need to cast this integer to a float for the division to work, and then we will just multiply the delay coefficient that we have computed here from our data with this seconds per line value. And then we can simply cast this to a time and feed it into the trigger delay, which will get its in trigger from the online of the clock. And now we can reproduce the imperfect timing that we had in our original MIDI file. Which is nothing special in this case, but this is just a demonstration how to work this out. The last kind of data that we have was volume data or velocity data. And to make use of this, we will once again add a get column node, and we will set the path to synth/volume. We'll grab it from the same input pattern and we'll trigger it on the line. Then we'll actually get our value. But let's actually not trigger this using the online, but we will only need a new volume value whenever we actually trigger a new node. And we already have this trigger right here. So we can connect this trigger up to our get so that we only get a new volume value whenever we actually play a note, whenever the note value is greater than 0. So we can hook up the index to our get and then take this value and cast it to a float and divide it by 127 to get a value between 0 and 1, which we can use to scale our audio output with by simply multiplying audio by float and then hooking this back into our output. This graph has become a little messy, but this is just a quick demonstration of how to set up something like a Metasound that plays back the Concord pattern information. So let's take a listen. For reference, let's take a listen to what we recorded in the first place. And we can actually see that because I actually went a little bit over 2 bars, which is more than 32 lines of 16th notes, it actually cuts off and loops back before we hear the last note in our Metasound. Alright, I hope this gave you an intuition how you can use MIDI with Concord and Metasounds to simply play back the MIDI. Concord is actually about generating these patterns in real time and not just importing and playing them back, but you can check the other tutorials on this channel for more info about that. Have a good one of whatever you're having.